Welcome to your own channel NCERT teaching. Students, today we are going to discuss about chapter number 4 of class 8 science, which is materials, metals and non-metals. In class 7th we learned many things about atoms and molecules about and the properties of things, and then we learned some idea about acid, base and pH. So those ideas will be helpful for this chapter also. So let's start our chapter. Materials, metals and non-metals. So I'm sure we all are aware about metals: iron, copper, zinc, aluminium, silver, gold. Okay, these are some metals and some mixture of these metals, for example steel, uh, alloy, brass, we see in day-to-day life. We all are aware about metals, and most of the students will are also, I am sure that they are also aware about the properties of metals, because clearly we see the shine of metals, the sound they produce. We are going to discuss those properties which we are familiar, but yes, there we may not be as much familiar with non-metals. So let us discuss those points which we are going to study in this chapter. Physical properties of what? Metals and non-metals, which is the topic of our chapter. Then chemical properties of metals and non-metals. Which chemical properties? Reaction with oxygen, reaction with water, reaction with acids and bases. So we will discuss or study these four properties: reaction with oxygen, water, acids and bases of metals and non-metals. So we will divide these properties into 8 sections. Then uses of metals and non-metals. So these are some properties of metals and non-metals. So as I have mentioned several times in class 7th science videos also and science videos also, that this universe or all things in this universe are made up of tiny particles which are called atoms. They are the smallest particles. You can we can say in class 8 level, although they have some subparticles which are called electron, proton and neutrons. Then the materials we see in this world are the result of combination of some atoms in certain proportion. Those combinations are called molecules. Actually molecules are the unit of materials which we see. So if we are seeing salt or sugar, so the smallest particle which have the property of sugar or salt will be a molecule, not atom. So molecule is the smallest particle which retains the properties of that material. So we have roughly 100 to 110 or 118. This number may vary book to book, or depends on the level in which you are studying. So roughly we will take 100. So we have 100 atoms in this world, but yes, we have so many variety of materials, because there are several possibilities of combinations of these atoms which are called molecules. So let's discuss about the properties of metals first. So properties of metals, I think we all are aware. They are solid. If you imagine about iron, aluminum, steel, zinc, copper, they are solid, we see. But if you are aware of mercury, okay, if you are not aware about mercury, then if you remember thermometer, we learned about thermometer in class 7th, many types of thermometer. If you remember that topic from class 7th, you will be able to recall that thermometer have one shiny liquid inside which is called mercury. And when when we want to measure temperature of anything with the help of thermometer, that shiny liquid rises according to the temperature, and this is how we measure the temperature of anything. Okay, so that shiny material is a metal which is in liquid state, and that liquid metal is called mercury. So this is what we call mercury. Mercury is a liquid metal. So except mercury, all metals are solid. Metals are hard. Okay, most of the metals are hard. You can imagine the handles of your door, your refrigerator is made up of metal. Many parts of your vehicles and kitchen utensils are made up of metal. They are hard. But lithium, potassium and sodium, these are some metals which are not hard. Metals have metallic lusters. What do you mean by luster? See, luster means they are shiny. You can, if you imagine coal, wood, and then stones, and if you imagine steel, zinc, copper, silver, gold, iron, then you can easily imagine what I'm trying to say. They are shiny, metals are shiny. Okay, this is a very indicative property of metal. They are malleable. What do you mean by malleable? You can see written here, they can be beaten into thin sheets. So if you beat a piece of or crystal of sugar or salt, when you beat with hammer, what will happen? That sugar or salt will be broken down into pieces. If you beat coal or wood, what will happen? If you beat a stone, what will happen? It can be broken down into several pieces. But if you beat aluminum things, or if you beat utensils, they do not break easily. Sometimes they deformed, or they change their shape. If you keep beating aluminum wires or iron nails, they sometimes they get flattened. Okay, so this property of uh, converting into thin sheets by beating is called malleability. So metals are malleable and they are ductile. What do we mean by ductile? We can we can use metals for making wires. So they can be drawn into wires. I am sure that you have seen wires of copper and aluminum. Copper wires we use in electrical appliances, in our electrical supply. Metals have high melting points. What do you mean by high melting points? If you see ice, so ice we see in when we keep water in very cold temperature in our refrigerator, in freezer, it becomes solid, it solidifies, it becomes ice. But when in room temperature, it becomes liquid, and when we boil it, it becomes vapor. So in same way, anything can be liquefied if it is possible for that thing. But when we use utensils, kitchen utensils, to boil milk, to boil water, we are not seeing utensils melting in day-to-day life. So the temperature we see 100 degrees centigrade, 150 degrees centigrade, these temperatures are not sufficient to melt metals. So metals have very high melting points. So the meaning of this, that you cannot easily melt them. Of course, we are melting iron, we are melting copper, we are melting zinc to make several things. But in industries, we have a specific instrument for that, and there is very high temperature, 1000 degrees centigrade. You can imagine very high temperature we are using. But again, there are exceptions. So we have gallium and cesium. They are two metals which have low melting point. So you will have exceptions everywhere, and we need to remember. Okay, this is the point. We need to remember every detail which is given in our NCERT. I have mentioned this in several times in my videos. Okay, so they can melt in the palm of the hand. So they are having very low melting points. Metals have high boiling points. Again, same thing. If you can't melt them easily, you can't boil them easily. Metals are good conductor of it. Very good. Okay, see, we are using kitchen utensils for cooking food. Why we are using kitchen utensils of metals? Because metals can heat easily. That is why we are able to cook food easily. We are not using wooden utensils to cook our food. Clear? So you can see the difference. So and what is written, best conductors are silver and copper, and we are using copper utensils most of the time. Nowadays we are using actually steel utensils. It is a mixture of iron plus other things. Poor conductors are lead and mercury. They are good conductor of electricity also. What do you mean by good conductor of electricity? Electricity can flow in wires, or electricity can flow in metals. That is why every electrical wire is made up of metal. Most of the time it is copper, and it is coated with plastic. So you can imagine in previous chapter, chapter number 3, about synthetic fibers and plastic, you can check out other videos of class 8 and 7 science if you want to know my previous discussions. If you want to engage in my previous discussion, you can check out in the description below. So there I mentioned that plastic is a poor conductor of heat and electricity. That is why we use plastic coatings where on the electrical appliances, on the electrical wires. So wire is made up of metals because they are good conductor of electricity, and they are coated with plastic because plastic is a poor conductor of electricity. So we have a best combination of metal and non-metal. Then they are good conductor of heat, the metals. That is why we are using kitchen utensils made up of metals. But yes, we are using handle of again plastic, but yes, that is a different plastic which is called thermosetting plastic. Okay, we have discussed thermoplastic, thermosetting plastic and other concepts of plastic in our previous chapter, chapter number 3. And they are sonorous. What do you mean by sonorous? So I am sure that you are aware about your bell in your school, because bell timing are very important. Because of bell timing we start our session, then because of bell we know that okay, there is a recess or break, and finally when it's time to leave, again there is a bell sound. So most of the time bells are made up of metals, even electrical bells are also made up of metals. So when we beat metals, they produce sound. And very simple observation, I can take example of kitchen. When we mistakenly, when we some utensils are fall down mistakenly, then they produce so much of sound. Okay, we all get irritated because of that sound. So utensils produce sound, or bell produce sound because metals are sonorous. This property is called sonorous. They produce sound when beaten. If you beat wood, it will not produce that much of sound. If you beat clothes, okay. So you can, I think we all are aware about these properties, but there are certain technical names in this chapter which we are encountering. And one more thing, see, in our NCERT textbook, students, you will encounter certain activities and tables. So those activities and tables are very useful for understanding this chapter. That is why I have included some images and tables. So you try to complete this. This may be your homework. You open your chapter in NCERT textbook and you try to complete these tables. Very easy to complete. But when you engage in these activities, you will be able to better able to understand these concepts. Okay. So this picture, figure 4.1, taken as it is from NCERT, is showing we can beat iron nails or aluminum nails and we can flat them. This is showing the ductile property. Okay. Then next is showing the good conductor of heat and electricity, that property of metal. Then we are having two tables. Let's see these tables about the hardness or appearance of metals, and then we have uh, malleability of metal. So these tables and activities are designed to engage us, to engage you as students in this chapter, so that you can have a better understanding of this chapter. Next thing is physical properties of known metals. So they, you can take opposite statements, so it will be easier to understand. Okay. So when we say that okay, metals are hard, so you can say okay, non-metals are not so much hard. So non-metals are soft, except diamond. Exceptions are everywhere. Diamond is a non-metal which is very shiny plus hard. So when we say okay, metals are shiny, non-metals are not shiny, but you will say okay, a diamond is shiny and it is hard. So next thing, metals do not have a lustrous property. Again, what is written here, there are some crystals which are shiny. Then they are not malleable, they are not ductile. Okay. They have low melting points, low boiling points. They are poor conductor of, bad conductor of heat, bad conductor of electricity, not sonorous. Simply, if you remember previous statements of metals, if you simply put not or opposite statements, those statements will be true about the physical properties of known metals. Next thing, reactions. Okay, these reactions are very important because of examination point of view and solving our NCERT questions also. So reaction with oxygen. What do you mean by reaction of oxygen? Like okay, let's first see this image of rusting. I am sure that we all are aware about rust. Iron things, or things which are made up of iron. Most of the time we see rust, iron rust. It is a reaction of iron with moisture and with oxygen. So iron oxide is actually rust, and we can see the property of rust also. And if you can recall from your class 7th, how can we check anything which is acidic or basic by using a pH paper, what color it turns, red or blue. Okay, sorry, yes, about litmus paper, not pH paper, sorry. By pH paper you will see some colors and you will conclude some numbers, and that is about pH. Below 7 acidic, above 7 basic, and approximately 7 will be neutral. Okay, let's only talk about litmus paper here. So you can recall class 7th chapter for this. This will be a recall activity for you. So now we have seen this diagram. Let's zoom the text and see the chemical properties of metals one by one. So first thing, that metals react with oxygen to form metal oxide, and actually iron oxide is actually the rust. So when copper reacts with oxygen, it will make copper oxide, aluminum will make aluminum oxide, and the same way you can see many reactions. Okay, when you see these reactions, actually these alphabetical formula combined with some mathematical expressions. Okay, Al2O3, it means aluminum oxide. So it means aluminum 2 atoms, oxygen 3 atoms combined with each other, Al2O3 is single molecule of aluminum oxide, and this 2 indicates the number of molecules. You will learn more about balancing equations and about equations in class 9, in your next class, 9 science. Okay, so don't worry about these equations. There is actually some formulas which are indicating the number of atoms in their molecules of substances. Okay, so this is about reaction of with oxygen, they make oxides, and rust is also a iron oxide. You can see the formula here. So you can say Fe2O3 is the formula for rust. Clear? Next thing, reaction. Okay, the reactivity of different metals with oxygen is different. We have seen by these equations. Okay, here is the statements or conclusions from those reactions. If magnesium is heated, it burns with bright flame. If you magnesium ribbon, if you have performed your activity in class 7 science, this activity is there, burning of magnesium ribbon. Okay, so in chemistry lab, the magnesium ribbon is available in chemistry lab, and we can burn it. It is simple metal ribbon. When you burn it, it burns with flame, bright flame, and then we find some white powder. Okay, so if it I will make one video also of this activity if it is possible when I go to school, and I will share with you. And next thing, if iron is heated, it glows brightly. I think you have seen this activity, because there are many instances in day-to-day life when we burn iron. If copper is heated, it do not burn but forms a black coating of copper oxide. You can see these type of coatings when you use copper utensil for cooking something. Next thing, silver and gold do not react with oxygen at high temperatures, even at high temperatures. You know, silver and gold, I think we all are familiar with these metals. Actually we use jewelry made up of these metals. Why we use jewelry? Very simple, to understand that they are less reactive for anything. So when you will learn about the properties of metals, for every property, silver and gold are the less reactive metals. So when you ask your mother or your sister or any other in your family that do they like to wear jewelry of copper and iron, they will say no, because they are reactive. If you wear jewelry of iron, it get rust, it may irritate your skin, it can cause skin problems. If you wear jewelry of copper, it will have some green deposit. If you have seen some green deposits in the copper utensils and copper things. So yes, silver and gold are very less reactive, and that is why they are very shiny, and people love to wear jewelry of silver and gold, and they are very expensive also. Sometimes we use a coating of gold, not the complete gold, for making jewelries. That is a different point. Next thing, some metals like magnesium, aluminum, zinc, lead, etc. form an oxide layer over it, which prevents further oxidation. They are called self-protecting metals. Okay, if you remember, girls and boys, in our home also we used to color metal things. We used to color iron things to prevent the rusting. Why we used to color? Because that color actually covers make a coating of the protective layer which do not rust. In the same way, if you see the tapes in your bathroom and the handles of your doors, they are very shiny for the first time, although they are made up of iron. Why? Because there is another metal which is we have coating of that metal on iron objects. Why? To prevent the rusting. So in the same way, these metals which are mentioned here, aluminum, magnesium, zinc, lead, they make their own coating. That is why they are called self-protecting metals. Very easy to understand. And again, these are some images from our NCERT textbook, figure 4.4 and 4a and b. So these, by these images you can see the actual
reactions are happening. And if it is possible, you must visit your chemistry lab. And I am sure if you have visited chemistry lab, you have seen many type of chemicals and metals and non-metals there. And okay, I am pointing one thing. If you have visited chemistry lab, I am sure that you have seen some blue color solutions in glass bottles, or blue color powder or crystals in glass bottles. If you have visited chemistry lab, you must have seen, although you do not, if you know or don't know the name of that product, but you have seen. And I am saying that that product is copper sulfate. Let me write the chemical formula: CuSO4. Copper sulfate is a chemical which is blue in color, copper sulfate. So if you have seen blue color liquid in glass bottles in chemistry lab, that was copper sulfate. If you have seen blue color powder in glass bottles in chemistry, that most of the time, okay, I am not saying that it is 100% true, but most of the time if you have seen this type of thing, that is copper sulfate crystals. So copper sulfate powder, copper sulfate liquid. I will take this concept in my further slides of this same presentation. Okay, now let's see some chemical formulas of reaction with water. So when these metals react with water, they make some chemicals. For example, NaOH, KOH, CaOH2, Al2O3, and the names of these chemicals, the conclusions are discussed here. The sodium and potassium react violently with the cold water to form sodium hydroxide. You know, sodium is a metal. If you put the sodium in water, it will burn. See, this is the diagram, not diagram, image, original image from your NCERT. And we cannot perform this activity in your home, but you can perform this activity with the guidance of your teacher in chemistry lab. And actually there are so many activities in higher classes, but you can see the demonstrations in your chemistry lab. Okay, so very simple. If you put sodium in water, it burns with flames. So very spectacular to see. That is why it is written here, they can catch fire. Next thing, calcium react with less violently with water to make calcium hydroxide. And I am sure that you have seen tuna at your home, that is calcium. Magnesium reacted only with hot water, okay, not with cold water. And metals like aluminum, iron, zinc, they only react with the steam. Okay, that is why we sometimes we use their utensils to cook our food. If they react with water, we are not able to cook our food. So if you apply your general logic at your home, at your kitchen, that's many of the concepts you can understand, many of the questions you can answer easily. Metals like lead, copper, silver, gold do not react with water. Again, we are using copper utensils, we are using silver and gold as jewelry. So by applying this simple general logic, you will be able to understand these properties very effectively. Next thing, reaction of metals with acids. Okay, now again you need to recall from class 7 science. If you want my help for this recalling, you can check out my previous videos of class 7th also in the description link below. So what are acid, what are bases, you can recall from class 7th. And we have some tests for acid and base also, for about pH paper and litmus paper from. They have some properties. So metals react with the acids and bases, and what they make, these are some equations. You can see they are making hydrogen gas plus another compound. So for the above metals, the decreasing order of reactivity is, okay, what do you mean by decreasing order of reactivity? Okay, see, you can see magnesium, then this sign, then aluminum, again this sign. So this sign indicates that iron is the less reactive, zinc is more reactive, aluminum is more reactive, and magnesium is most reactive for above 4 reactions. So okay, we say, okay, metals are reactive, metals are hard, they are shiny, they are sonorous, but you can also imagine this property is not same for all metals. All are shiny, but silver is more shiny than iron. You can see copper is more shiny than iron. Then if we beat iron nail and aluminum, you can easily understand that aluminum is more malleable than iron. So okay, we have some common properties for metal, but yes, every metal have some property more or less. In the same way, if they react with acid, some metals will react fast, some metals will react slow. So for these reactions particular, magnesium is the most reactive metal. Copper, silver and gold do not react with the dilute HCl. They will not react in most of the things. That is why we are using them in jewelry. Hydrogen gas is not evolved when metals react with nitric acid. Okay, that is also acid. Otherwise, in these for hydrochloric acid HCl, they are releasing hydrogen gas. Okay, and there is some chemical test also in higher classes for hydrogen gas. That is why we can we can know, okay, this gas is hydrogen gas. Reaction with bases again the same, they are again producing hydrogen gas. Okay, so this is about the reaction of acid and bases, and all properties are discussed very briefly or overview in class 8 level. So there is no need to worry, but only the need is only to read your NCERT and engage with the activities actively. Okay, one more thing, chemical properties of known metals. So far we have discussed chemical properties of metals, so they are actually lengthy. Chemical properties of known metals are discussed very briefly. So again same things, reaction with oxygen, reaction with water, reaction with acid, and reaction with bases. So reaction with oxygen, known metals react with oxygen to form known metal oxides like metal oxides. Okay, but they are not producing hydrogen gas here, you can see, and the metals are producing hydrogen. So this is the difference, that non-metals do not produce hydrogen gas with acids. I'm sorry, it is about oxygen, not about acids. Non-metals generally do not react with acids, so actually they do not produce hydrogen gas also. Okay, so this was the difference I was mistakenly saying in the reaction with oxygen. So in oxygen we have seen the oxygen oxides there, metal oxides, which are called rust in case of iron. So reaction with water, they generally do not react with water. Okay, they may be very reactive in air. Okay, such non-metals are stored in water. Okay, you know that if the metal react with water, for example sodium, we preserve them in kerosene oil or in any other thing. So it depends on the thing, whether it is reacting with water, whether it is reacting with air, or it is reacting with whom. So we store in the opposite thing. So if non-metals are reacting with air, we store them in water. Okay, see, to prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. So these are very simple properties to understand. One more thing, okay, here you can see a reactivity series. A reactivity series you can see, it is a decreasing order. So you can say that potassium is the most reactive metal, and gold is the less reactive metal, or least reactive metal. This decreasing order, if you can see, I will point out one or two metals: zinc, copper, and iron. So here you can see easily that copper, if we consider only these three metals, zinc, iron, and copper, you can see, okay, zinc is more reactive than copper, correct, and iron is also more reactive than copper, but copper is less reactive than iron and less reactive than zinc. I will use this concept in my next slide. Let's discuss that slide. These slides is about displacement reactions. What do you mean by displacement reaction? Very interesting to know. So as I have said two things. First thing, I have said if you see this type of blue solution in glass beaker or glass bottle, that will be copper sulfate. So this is copper sulfate. What will happen if we put iron nail in this copper sulfate? Okay, forget about these all beakers and all these reactions. This seems complex, but it is very easy to understand. So if you place iron nail simply in this solution, after some time what will happen, this solution will become green. This solution will become green. Why this solution will become green? Very easy to understand. Okay, and this solution will become green, and if you take out the iron nail, if you take out the iron nail from the solution, if you take out the iron nail from this solution, after some time when this solution becomes green out of blue or from blue, you will see that it is becoming one layer of copper is there on this iron nail. You know the color of copper is orange yellowish color of copper. So you can clearly see when you touch the iron nail, you will see, you can feel copper on your hand also. A deposit of copper is there in this iron nail. So let's discuss only this activity with the help of some description and some reaction. So actually this is a chemical reaction which is called displacement reaction, and if you pay attention to the name displacement, it means replacing one. How so in displacement reaction what happens, a more reactive metal replaces or displaces less reactive metal from its salt solution. I am repeating again, more reactive metal displaces less reactive metal from its solution. Okay, so this is why, that is why I was discussing again, I must show you this series. I was discussing this series for discussing this experiment. So let's only pay attention to iron and copper. So which is more reactive? From this series we can say, okay, iron is more reactive than copper. So iron can displace copper, but copper cannot displace iron. Okay, let's focus on only these two metals, then you will be able to understand easily these reactions. And one activity is there in our NCERT textbook. I have taken screenshots of those activity as it is from NCERT. So here there are 5 beakers, different solutions, and in these beakers it was said to record the activities, but we cannot perform the activity here, but I can give you some idea. So here you can see in beaker A and B we have copper sulfate solution, okay, and you can see labeling here. So in beaker A and B we have copper sulfate solution, in beaker C we have zinc sulfate solution, in beaker D we have iron sulfate solution, and in beaker E we have zinc sulfate solution again. And what we have put in these beakers in A, B, C, D and E, we have zinc in beaker A, iron nail. The activity I was discussing in beaker was about beaker B, okay, turning of this blue solution into green. Then in C we are having some copper turnings, in D we also have some copper turnings, in E we have again some iron nail. We can make iron nail like this purple. So let's make this iron nail purple. So the purpose of these 5 beakers or these activities is simply to understand this concept. A more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace the more reactive metal. Let us understand theoretically this thing. See, so we have copper sulfate in this solution, and we have zinc in this solution also. So zinc is more reactive, we have seen in the reactive series. So zinc will replace the copper in the copper sulfate. Now it is not copper sulfate anymore, it will become zinc sulfate, that is why it has this cyan color, okay. Then we have iron nail in the copper sulfate, again iron will replace copper in the copper sulfate solution and it will become iron sulfate, green in color. Now here you can see we have zinc sulfate and iron sulfate and we have copper in it. Now we know the copper is less reactive than zinc, so the color of the solution is the same, because copper cannot replace zinc, because copper is less reactive and zinc is more reactive. Again you can see in beaker number D we have iron sulfate solution and we have copper turnings in that solution, but yes, again copper is less reactive than iron, it cannot replace it. And finally again we have zinc sulfate solution and iron nail in it. And if you want to see revise, you want to see this series again, you can see here. So I was discussing 3 things: iron, zinc and copper. Here you can see copper is clearly less reactive, iron and zinc are clearly more reactive than copper. But if you compare iron with zinc, zinc is more reactive, iron is less reactive, okay. Keep in this in mind, zinc is more reactive than iron. Now let's see. So we have zinc sulfate solution and we have iron in it. So what you can imagine, iron is less reactive than zinc na, so it cannot replace. So simply you will not see any color change in because C, D and E, clearly you can see, but we are seeing color change in beaker A and B. Very simple, because A is having zinc, B is having iron. And we not only see color change in a solution, but you will see here, you can see, if you are able to notice that these iron nails also have some deposition of copper, as I have discussed previously. So this is about displacement reaction, very easy, and these are some chemical reactions which I have discussed in the first and second beaker, because in beaker number C, D and E there was no displacement reaction, because in those beakers C and D, copper is less reactive than zinc and iron. And finally in beaker E, iron was again less reactive. So in for A and B beaker, you can see copper sulfate plus zinc we are having in A. So zinc is going here replacing copper, so it is becoming zinc sulfate solution plus copper. Again copper sulfate plus iron in beaker B. So iron was displacing copper from this copper sulfate solution, it is becoming iron sulfate, and this copper is separated and this copper will deposit on the iron nail, and that is why we see color change in beaker A and B, and we see deposition of copper on iron ore. I hope that I made some sense. I was able to make you understand about displacement reactions. If you are finding this difficult, you can because it is, you can rewind this video and read your NCERT textbook. You will definitely get the point. Very simple to understand, very important for examination point of view. This question comes many times, several times, and in several forms. Sometimes if you are aware about high order thinking skills or high order thinking questions, and nowadays there are, the pattern of question paper is also changing, you can see. So this is very important concept for that purpose also. Next thing and the last thing, very simple uses of metals and non-metals, very easy to understand. That is why I included these in single slide. So uses of metals and non-metals, I hope that you have got most of the idea. So we use metals in machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water bottles, and many things, many more things. We use in making electrical wires, musical instruments, making alloys. Very simple notion, and these are very few. You can imagine for more uses. Even I am sure that you are aware about more uses. You can write them down also. The non-metals we are using. So the things for this level you can understand, girls and boys. The things which are not metals are non-metals. So we are using oxygen for breathing. That is also non-metal. Fertilizers, nitrogen, phosphorus, potassium, again we are using, we have seen these things in crop production and management also, and microorganisms chapter number 2, we have discussed these things in both of the chapters. Then purification process, if you know about the use of chlorine, we use chlorine to disinfect the water, so chlorine is also a non-metal. Then we use iodine in healthcare, for healthcare use, and we use sulfur for firecrackers and phosphorus also. So these are very few uses, there are so many uses. So these are about uses of metals and non-metals. So again I want to discuss, because our learning outcomes. So if you have fulfilled this learning outcome, then the purpose of this video is solved. So again what we have discussed, three things: physical properties, chemical properties, and uses of what? Metals and non-metals. But I divided this presentation into separate slides. Then physical properties of metals, then physical properties of non-metals, chemical properties of metals, chemical properties of non-metals. Which chemical properties? Reaction with oxygen, water, acid and base, then uses of metals and non-metals. So I hope I made some sense. Thank you so much for you all for being in till the end of the video. Thank you so much for your patient listening, and I will try to make my next video on chapter number 5, coal and petroleum, of the same class 8 science. So thank you so much for listening.